Hi, my name is Drew Dawson, and this is my constant velocity lab experiment. Can I predict the future? What happens when force is applied to an object? The purpose of this experiment is to understand constant velocity using Newton's second law, compare predicted and tested motion, discuss what happens if we flip the axis, and possible flaws in the experiment. My experimental procedure starts with me recording myself rolling a ball across my driveway. I put this recording in the tracker program. The tracker program analyzes multiple positions of the object at different times. Then create a computational model that follows Newton's second law. I plotted the information from both the tracker and the computational model in a graph. Lastly, I compared the two sets of information displayed in the graph. Newton's second law explains how a force acts on a system, causing a zero change in momentum and the velocity remains the same. Here, the ball is the system and everything else is the surroundings. After analyzing and gathering the values of the position of the ball from the tracker app, I moved on to the computational model. Here's a picture of my code. As you know, we were provided with a starter code. From there, I kind of just added in the initial velocity, initial position, and the mass of the ball. Both the initial velocity and position was gathered from the tracker app. If you look further down, you see where it says update the object's velocity, and the next few lines says update the object's position. Here's where I applied the equations on the left to test Newton's law of motion. The code's purpose is to run through these equations as time progresses until it reaches 2.7 seconds. After running the code, I was provided with more values that I will use to put into the graph on the next slide. My position versus time graph displays two distinct lines, one purple line, one green line. The purple line represents the data I collected from GlowScript. It's the predicted negative X position of said basketball. The green line represents the data collected from Tracker. It's the observed negative X position of the basketball from the video. As you can see, both data series have an R-squared or goodness of fit of about 1, meaning in both the observed and predicted, the velocity of the ball is constant. The purple line has a R-squared value of 1, while the green line has an R-squared value of 0.997. So even though both lines back Newton's second law by having somewhat of a constant velocity, they are not identical. Discussion. What if the ball rolled the other way instead of negative X plus X? The results would be the same, except the slope would be positive with the two lines going up. The predicted line would be overestimated. Is it possible to say how many pushes needed for the net force to be 0? It is not possible because you do not know how many forces interact with your object. Also, forces can cancel each other out. If you were to do this again, would you solely rely on the computational model? No, I would not. The computational model represents a perfect world with no outside forces affecting the ball or object. This explains why the values from the observed don't perfectly match the predicted. In conclusion, this experiment, I observed the change in position of a ball. I compared these values to computational versions of the experiment to get a better understanding of Newton's second law. Some errors that may have came up in the experiment: wind speeds were 1 to 8 miles per hour that day. When using the tracker app, it was up to me to place the mouse in the middle of the object as it moved throughout the video. I could have not done that as accurately as it could have been. Both mass and diameter of my object was an estimate. It was an exact measurement. When rolling my ball, I could have always been more cautious and gentle with applying force. All in all, Newton's second law equation is backed by both the computational model and the observed data that I tracked. Thank you.